Hello, I'm Erkin here from MedPorium, and today we will start part 2 of the skeletal system. We will begin with the matrix of bone and then move on to the histology of bone. Now, the histology of bone is a high-yield topic, and it is seen on a lot of anatomy and physiology classes. So let's get started. The matrix of bone. 1/3 of osseous tissue consists of organic matter, and the other 2/3 are inorganic material. Let's take a look over here on the organic side. We have collagen, which mostly dominates this organic side, and then we have glycosaminoglycans, proteoglycans, and glycoproteins. Now, if we move over to the inorganic side, we have what we call hydroxyapatite, which dominates 85% of the inorganic side. And hydroxyapatite, all it is just a mixture of calcium and phosphate ions. It's just a compound of calcium and phosphate. And if we go below that, we have our three most common salts other than calcium and phosphate are potassium, magnesium, and sodium. So this is the matrix of bone, and if we move over to the ThinkPad, we will get a closer, in-depth view of what's going on here.
Now you may be wondering why I have a random picture of a fishing rod. Well, I thought it would be a good idea to incorporate some active recall on the information we just saw on the previous slide. Now, whenever a big fish grabs that hook and applies downward force, why does the rod not snap and break whenever it is getting bent and pulled? Well, this is because it has a mixture of polymers and ceramics. Those two substances by themselves are weak, but together it makes a strong rod. The bones, just like the rod, have a mixture of collagen and hydroxyapatite. This provides strength and flexibility. So over here, if we take a look at the rod, we have ceramics, and then we have flexible polymer fibers. Now when you translate that and mix them together, we have a strong, flexible rod that can handle force. The bones are very similar. Over here we have hydroxyapatite, which is calcium and phosphorus. And over here we have collagen, flexible collagen fibers. When we do that, we have a strong base for bone. Now, like I said, this provides strength and a little bit of flexibility to mend and adapt to force being applied. This is why our legs don't shatter whenever we're running or jumping from like monkey bars, for example.
Let's move on to the histology of bone. Let's start over here with this big picture in front of us. If we were to cut out a section of this piece of compact bone and view it under a microscope, this is what we would see here. We would get this image that I labeled here already, and I will explain these labels as we go on. So this right here is what we call histology. This is the histology of bone. Okay, and we will look at this and analyze this. Okay, viewed under the light microscope, compact bone displays an intricate series of concentric rings of bony tissue. Okay, now these concentric rings that I just explained are these rings here that I'm highlighting here in blue. These are called your lamellae. Okay, and these system of rings are organized into units called osteons. So these rings, lamellae, these rings called lamellae, make up an osteon. So this whole circle itself is an osteon. Okay. Now, at the center of each osteon is a central canal. So here we have another osteon. Okay. And in the center of that osteon, we have a central canal. This is your central canal that I am labeling here in green. This consists of your blood vessels and nerves. This canal contains nerves and blood cells, which service the bone cells within the osteon. Now, crossing the concentric rings of an osteon are a system of channels called perforating canals. Now, I don't have that labeled here, but your perforating canals are these canals. These are the canals that are perforating your central canal. So just think of the perforating canals are the canals that are running horizontally and that will perforate the central canal here. Now, the perforating canals, as I said, link one another, and surrounding each central canal are what we call lamellae. I mentioned that as well in the beginning. Now, once again, the lamellae, let me relabel that here. The lamellae are the rings that make up the osteons. So all these rings you see are osteons. All these are lamellae. All these rings here are lamellae. Let's get that into our heads. Now the rings of the osteon are made up of the lamellae, and the spaces within the rings are called lacunae. So these spaces, these random spaces here, I will be labeling in red. These spaces in between are called lacunae, okay? The spaces in between these rings are called lacunae. Now the osteocytes, let's label that in pink here, highlight that in pink. The osteocytes, once again, are these pink dots, or they're not dots, but they're cells. We can look at them as dots. These pink cells, and these osteocytes, once again, as I explained, they got trapped in the matrix of bone after creating this bone, and they pass chemical nutrients and not chemical nutrients, they pass chemicals, signals, and they pass nutrients and waste to one another. Now, osteocytes are trapped within the bone tissue they maintain. Ultramicroscopic extensions called canaliculi, as we can see here. I'm going to label that in yellow. Let's label that here in green. The canaliculi are these, I don't know if you can see it, but these are the tubes. They're kind of tubes that connect each osteocyte to one another. That's how they pass their chemical signals and their nutrients. Now, the spaces between the osteons are filled with material called interstitial lamellae. So that's basically just lamellae. I've explained that a couple of times now. These are just the rings that are in between the osteons that don't actually make up an osteon. So remember, lamellae is equal to the rings. The periosteum surrounds the bone and is the place where osteocytes arise. In their original form, osteocytes are highly active osteoblasts that make up the protein, collagen, and hydroxyapatite of bone. But once they get trapped into that matrix, then they will turn into osteocytes, which end up just nourishing and removing waste from the surrounding bone. So over here, let's highlight this in blue. Okay, so here the periosteum, that's that, if we can recall, the protective membrane of a long bone and also flat bones. Here we can see that this area here is the periosteum. Okay, and once again, I want to emphasize the use of the canaliculi and the osteocytes. These are probably the most important parts of the histology of bone. Over here, when we labeled this in green, these little tubes and these little canals connect osteocyte with osteocyte. So these outer osteocytes communicate, and send their waste to this osteocyte. Eventually, these outer osteocytes from the outer layer their waste will end up traveling through canaliculi into osteocytes from the inner layer, and then the osteocytes in the inner layer will take it into the central canal, and the central canal will take it to the perforating canal, and eventually it will follow that, and it will leave and exit the bone through these big canals here, these big blood vessels here. And that, ladies and gentlemen, concludes the end of part 2. The topics we discussed was the matrix of bone, what makes up bone, and the histology of bone. Now remember, the histology of bone is a high-yield topic and will be seen on a lot of anatomy and physiology tests. So don't forget that a pomodoro a day will make you a doctor someday.